Good morning students. In the last session we have learnt about introductions to states of matter, intermolecular forces, types of van der Waals forces like dipole forces, London force or dispersion force, induced dipole force, etc. Then we have also studied about thermal energy, intermolecular forces, variation of thermal energy and intermolecular forces in the case of solids, liquid, gases, etc. Then we studied about characteristics of gases and some generalization in the laws. They are called gas laws. Under the gas laws, we have studied first law, that is Boyle's law. Boyle's law, mathematical form is PV is equal to constant, or we can also use it as P1 V1 is equal to P2 V2, means at a different condition, two different conditions. Okay, let's solve some problems related to Boyle's law. Okay, here one problem is given: 10 m³ of hydrogen gas under 1 bar pressure are contained in a cylinder which has a movable piston. The piston is moved in until the same mass of gas occupies 2 m³ at the same temperature. Find the pressure in the cylinder. By looking at the problem, we can say that initially the pressure was 1 bar. So from the given data, we can write V1 is equal to initial volume. It is given as 10 m³. What is the pressure at that time? That is, let us take it as P1 as 1 bar. Next, the piston is moved in until the same mass of gas. So mass of the gas has not changed. It occupies 2 m³. So when piston is moved in, the volume reduces to 2 dm³. dm³ means decimeter cube or liter. Okay. At the same temperature. So temperature has kept constant. Find the pressure in the cylinder. So we have to calculate P2. What's the value of P2? According to Boyle's law, we know that P1 V1 is equal to P2 V2. What we have to find out? P2. We know that when volume V1 becomes V2, volume has reduced. But what happens to pressure? When volume is reduced, pressure has to increase. So answer we should get more than 1 bar. Okay? Let us substitute this one. P2 is equal to P1 V1 divided by V2. Let us substitute. P1 1 bar, V1 10 m³ divided by V2 2. So 10 divided by 2 is equal to 5. Unit of pressure is bar. So here 5 bar is the answer. So we have got the answer. See, volume P1 10 m³ is reduced to 2 m³. Then pressure has to increase. So 1 bar is increased to 5. Okay. So find the pressure in the cylinder is the answer is 5 bar. Similarly, let's move to the next problem. That is, a balloon is filled with hydrogen gas at the room temperature. It will burst if pressure exceeds 0.2 bar. If the pressure is more than 0.2 bar, balloon bursts. If at 1 bar pressure the gas occupies 2.2 liters, volume up to what volume can the balloon be expanded? More than that means it will burst. So here also, from the given data, P1, P2, V1, V2. Okay. A balloon is filled with hydrogen gas at the room temperature. It will burst if pressure exceeds 0.2 bar. Okay. If at 1 bar pressure the gas occupies 2.2 liters. So 1 bar pressure, let us take P1 1 bar. What is the volume occupied by we can say that here, in order to that balloon may be burst out, the volume should be less than 11.35 liters. Okay, so answer is 11.35 liters. Okay, let's start with the next law, that is Charles law, which relates volume and temperature. So we can also say that volume, temperature relationship. Two scientists, Charles and Gay-Lussac's, they performed several experiments to relate the volume and temperature. According to this law, later it is called as a Charles law. According to this law, the statement is at constant pressure, the volume of given mass of gas, the volume of given mass of gas increases or decreases by 1 by 273.15 volume at 0 degrees Celsius for every 1 degree rise or fall in temperature. Once again, the statement of the Charles law is at constant pressure. So pressure is kept constant. Volume and temperature, how they vary. The volume of given mass of gas increases or decreases by 1 by 273.15 volume at 0 degrees Celsius for every 1 degree rise or fall in the temperature. For this purpose, let us take, let V naught is the volume at 0 degrees Celsius and the temperature is raised to T degrees Celsius. Then volume becomes Vt. So according to Charles law, the mathematical form we can write it as volume at T degrees Celsius is equal to volume at 0 degrees Celsius. It increases or decreases by 1 by 273.15. So V naught divided by 273.15 into T. I take V naught outside, so we get 1 plus T by 273.15. Okay, it is also equal to, taking the common denominator, 273.15 denominator, here 273.15 plus T. So we can write the Boyle's law like this. Vt is equal to V naught into 273.15 plus T divided by 273.15. Okay. If temperature at T degrees Celsius, how do you convert degrees Celsius to Kelvin? By adding 273.15. So temperature at T degrees Celsius is nothing but 273.15 plus T. which is a constant. Which is a constant. Okay. From this relation, we can say that V2 by V1 is equal to T2 by T1 is equal to K. Right? So we can write it as, how it is possible? We have converted 273.15 plus T as TT, 273.15 as T0. So substituting we get VT is equal to V0 into TT divided by T0. So VT by V0 is equal to TT by T0, or we can also change this as V2 by T2 is equal to V1 by T1, a constant K. If you take this mathematical expression, we can write it as V2 or V is equal to K into T. Am I right? V2 by T2 is equal to K, or V1 by T1 is equal to K. Anyone you can take. V is equal to K into T. Okay? From this equation, we can also say that V is proportional to T. So from this mathematical expression, we can also state the Charles law as at constant pressure for a given mass of gas, for a given mass of gas, volume is directly proportional to temperature. Volume is directly proportional to temperature. That means when volume increases, temperature increases. It also increases. Directly proportional meaning is what? Whatever present in left hand side increases, whatever present in right hand side also increases. So this is the which one? One more statement or one more way to produce what? Charles law. V is proportional to T at constant pressure for a given mass of gas. For a given mass of gas, volume is directly proportional to temperature. Okay. So we have concluded that volume is directly proportional to temperature at constant pressure. Here, one more concept comes, that is absolute zero. What is absolute zero? Absolute zero means it is hypothetical in nature. Hypothetical ಅಂದ್ರೇನು? Just ಊಹೆ ಮಾಡಬಹುದಷ್ಟೇ, ರಿಯಲ್ ಅಲ್ಲ, ಊಹೆ ಮಾಡಬಹುದಷ್ಟೇ. That is hypothetical in nature. The temperature minus 273.15 degrees Celsius. Okay? This is called as absolute zero, because at this temperature, volume occupied by any gas is zero. Any gas is zero. Hence it is hypothetical in nature. So that is why minus 273.15 degrees Celsius is called as a absolute zero. What about its value in Kelvin scale? We have to add 273.15. So we get as, which is nothing but 0 Kelvin. So 0 Kelvin is also called as absolute zero. This scale was given by scientist called as Kelvin. Lord Kelvin has given this scale here, where lowest temperature is this one, means minus 273.15 degrees Celsius. Hence it is also called as absolute zero scale or Kelvin scale temperature. Kelvin scale temperature. It is also called as Kelvin scale temperature. So in the Kelvin scale temperature, lowest temperature is minus let's draw a graph of volume versus temperature. Temperature along x-axis in degrees Celsius. Volume along y-axis, it may be measured in terms of dB. So I start with minus 300 degrees Celsius, minus 200 degrees Celsius, minus 100 degrees Celsius, 0, next plus 100, plus 200, etc. Similarly, here volumes. If you plot a graph at constant pressure, for example, at pressure P1, this is the graph. At pressure P2, constant pressure it should be, so this is for at pressure P2. Similarly, pressure P3, this is the graph. Similarly, for pressure 4, this is the graph. We know that volume is directly proportional to temperature, means whenever volume increases, temperature has also increased. So, we will get a straight line. By extending these lines, all these lines meet at one point, that is 0 volume, but the temperature is minus 273.15 degrees Celsius. From this, we can say that by extending this straight line, all these straight lines crosses x-axis. All these points, lines meet at one point where volume should be 0, and that point is nothing but temperature, where temperature is minus 273.15 degrees Celsius. Okay, so from this also it is confirmed that the volume occupied by any gas at 273.15 degrees Celsius, minus 273.15 degrees Celsius is 0. Okay. Now, these graphs here, they are plotted at constant pressure. See, this is the graph at constant pressure, variation of volume versus temperature. This graph is straight line for constant pressure P2. This graph is for constant pressure P3. This graph is constant pressure P4. Here, P1 is less than P2, less than P3, less than P4. Since graph is plotted at constant pressure, these straight lines are plotted at constant pressure. These are called as isobars. Isobars means which is plotted at constant pressure. Okay. So this is about the plotting of volume versus temperature or variation of volume versus temperature. Remember, the pressure must be constant. But here 4 pressures are there. But for each one constant pressure. For each line is a constant pressure. Now let's solve some problems about Charles law. We know that according to Charles law, volume is directly proportional to temperature at constant pressure. Okay. Here is one problem. A certain amount of a gas at 27 degrees Celsius and 1 bar pressure occupies a volume of 25 meter cube. If the pressure is kept constant and the temperature is raised to 77 degrees Celsius, what will be the volume of the gas? From the given data, we can write at 27 degrees Celsius, 1 bar pressure is there. So I will write temperature 27 degrees Celsius, 1 bar pressure, but pressure kept constant. If the pressure is kept constant is given. So at temperature 27 degrees Celsius, I write 27 degrees Celsius in terms of Kelvin. So by adding 273.15, it will become 300.15 Kelvin. Okay. By the time, what is the volume? Volume is 25 meter cube. Let the unit is meter cube only. Kelvin. 350.15 Kelvin. Okay. But the question is, what will be the volume of the gas? So what are we find out? V2 we have to find out. Okay. We know that formula is what? V is proportional to T, or V1 divided by T1 is equal to V2 by T2. So V1 by T1 is equal to V2 by T2. What do you have to find out? V2. So from this expression, V2 is equal to V1 T2 divided by T1. Right? V2 is equal to V1 T2 divided by T1. Let's substitute. V1, what's the value? 25. T2, what's the value? 350.15 Kelvin. Divided by T1, what is the value? 300.15. On simplified days, we will get 29.16 meter cube. Volume is in terms of meter cube here. So answer will get 29.16 meter cube. Okay. We know that formula is V1 divided by T1 is equal to V2 by T2. Whenever temperature is 27 degrees Celsius, volume is 25 meter cube. When the temperature is raised to 77 degrees Celsius, what will be the volume? That is the question. So substituting in this formula, we will get V2 is equal to V1 T2 divided by T1. So substituting, we will get 29.16 meter. Okay, let us move to the next problem. A flask was heated from 27 degrees Celsius to 227 degrees Celsius at constant pressure. So at constant pressure means we can apply which one? Charles law. Calculate the volume of the flask if 0.1 dm cube of air measured at 227 degrees Celsius was expelled from the flask. So we can write here from the given data, let us say V1 is equal to V dm because 0.1 dm is expelled. So let's use the same unit, V dm. V2 is equal to, since 0.1 dm cube is expelled, so V2 is nothing but 0.1 more than V1. So V1 is nothing but V, so I write V plus 0.1 dm. What is the temperature? Initial temperature at volume V1, it is temperature T1 is equal to 27 degrees Celsius, which is nothing but by adding 273.15 Kelvin, we get the value in terms of Kelvin, that is 300.15 Kelvin. What about T2? It is increased to 227 degrees Celsius. Let us convert it into Kelvin by adding 273.15. So 273, 227, we get 500.15 Kelvin. Very simple. Substituting in the formula. We know that V1 divided by T1 is equal to V2 by T2. Okay. Now let's calculate V1 is equal to V2 into T1 divided by T2. Okay. V2 is nothing but V plus 0.1. T1 300 into 300.1 divided by T2 500.1. Okay. V1 is nothing but V only. So I bring this 500.15 into left hand side. We get 500.15 V is equal to 300.15 V plus 300.15.1 is equal to 30.1. 0.15. meter cube. The answer is 0.15 meter cube. Let us move to the next law, that is Gay-Lussac's law. This law relates pressure and temperature. Hence we can say that pressure-temperature relationship. What is the statement of this law? This states that at constant volume, pressure of given mass of gas varies directly with or directly proportional, something, right? Varies directly with temperature. Varies directly with temperature. At constant volume, pressure of given mass of gas varies directly with temperature. So we can write mathematically T is proportional to temperature, but remember at a constant volume. We can write it as, by removing the proportionality symbol, we can write it as P is equal to K into T, or P by T is equal to K, where K is a constant. K is a constant. So we can say that from this, P is proportional to T at constant volume, or P is equal to K into T. By removing this proportionality sign, we can use equal, but we have to include the constant K. So P is equal to K into T. Or if you bring this T to denominator of left hand side, you will get P by T is equal to K. We can also write it as P1 by T1 is equal to P2 by T2, which is a constant K. One of the very important application of this Gay-Lussac's law in the case of tires of automobiles. Tires of automobiles generally ಯಾವ ಟೈಮಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೋಡ್ ಆಗ್ತದೆ, ಬರ್ಸ್ಟ್ ಔಟ್ ಆಗುತ್ತೆ? ಇನ್ ಸಮ್ಮರ್ ಸೀಸನ್. ಯಾಕಾಗುತ್ತೆ ಸಮ್ಮರ್ ಸೀಸನಲ್ಲಿ? ಸಮ್ಮರ್ ಸೀಸನಲ್ಲಿ ಅಟ್ಮಾಸ್ಫಿಯರ್ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ. ಅಟ್ಮಾಸ್ಫಿಯರ್ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆದಾಗ ಟೈರ್ನ ಒಳಗಿಡುವ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾಕೆ? ವಿ ನೋ ದಟ್ ಅಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ವಾಲ್ಯೂಮ್ ಪ್ರೆಷರ್ ಇಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಟೆಂಪರೇಚರ್. ಸೊ ಹೊರಗಡೆ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗುವಾಗ ಟೈರ್ನ ಒಳಗಿರುವ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾವಾಗ? ಟೆಂಪರೇಚರ್, ಹೊರಗಡೆ ಇರುವ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಅದಕ್ಕೆ ಕೆಪಾಸಿಟಿ ಆಫ್ ಪರ್ಟಿಕ್ಯುಲರ್ ವಾಲ್ಯೂಮ್ನಷ್ಟೇ ಮಾತ್ರ ಇರುತ್ತೆ. ಆ ವಾಲ್ಯೂಮ್ ಕ್ರಾಸ್ ಮಾಡಲಿಕ್ಕೆ ಬೇರೆ ಎಕ್ಸ್ಟ್ರಾ ವಾಲ್ಯೂಮ್ ಆ್ಯಡ್ ಮಾಡಲಿಕ್ಕಿಲ್ಲ. ಟೈರ್ ದೊಡ್ಡದಾಗೋದಿಲ್ಲ, ಏನಾಗುತ್ತೆ? ಬಸ್ಟ್ ಔಟ್ ಆಗುತ್ತೆ. ಬಟ್ ದಿಸ್ ಹ್ಯಾಪನ್ಸ್ ಓನ್ಲಿ ಡ್ಯೂರಿಂಗ್ ಸಮ್ಮರ್. ಯಾಕೆ? ಸಮ್ಮರಲ್ಲಿ ಹೊರಗಿನ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಬಟ್ ಇನ್ ವಿಂಟರ್ ಇಟ್ ಈಸ್ ವೆರಿ ರೇರ್, ತುಂಬ ಕಡಿಮೆ. ಟೈರ್ಸ್ ಎದ್ದೋಗೋದು ಅಥವಾ ಎಕ್ಸ್ಪ್ಲೋಡ್ ಆಗೋದು ತುಂಬ ಕಡಿಮೆ. ಯಾಕೆ? ಹೊರಗಿನ ಟೆಂಪರೇಚರ್ ವಿಂಟರ್ ಸೀಸನಲ್ಲಿ ಕಡಿಮೆ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಟೈಮ್ ಬೈ ಟೈಮ್ ನಾವೇನು ಮಾಡಬೇಕಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಆಟೋಮೊಬೈಲ್ಸ್ನ ಟೈರ್ನ ಪ್ರಾಪರ್ಲಿ ಅಡ್ಜಸ್ಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಓಕೆ, ಸೊ ಸಿನ್ಸ್ ಪ್ರೆಷರ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು T at constant volume, as the outside the temperature increases, pressure inside the tires of automobiles also increases, so it bursts out. That is the application of which one? Gay-Lussac's law. Let us study the graph of variation of volume kept constant, variation of pressure versus temperature. Here temperature is taken along x-axis in terms of Kelvin. Pressure is taken along y-axis in terms of bar. Let us take 100 Kelvin, 200, 300, 400. If we plot a graph at different constant temperature, for example, temperature of V1, temperature of V2, sorry, volume of V2, volume of V3, but constant there, volume V4, and constant different temperature, volume 1, volume 2, volume 3, volume 4. If you expand these, all these straight lines pass through origin. Okay, remember we are plotting pressure versus temperature, but at constant volume. Here different volumes are taken. This is for constant volume V1, this graph is for constant volume V2, this straight line is for constant volume V3, this straight line is constant volume V4. So in all the cases we get a straight line passing through origin. Since here volume is kept constant, these straight lines also called as isopores. Isopores means which is at constant volume. As I said, according to Gay-Lussac's law, pressure is proportional to temperature at constant volume. So according to that we have plotted pressure along y-axis, temperature along x-axis in terms of Kelvin. We get a straight line. The first line is at constant volume V1 passing through origin. Second line corresponds to constant volume V2 passing through origin. Third line straight line passing through origin at constant volume V3. Fourth line corresponds to constant volume V4 passing through origin. Here volume V1 is less than V2, less than V3, less than V4. Okay students, let's solve some problems on Gay-Lussac's law. We know that according to Gay-Lussac's law, mathematical form I can say that P by T is constant or P1 by T1 is equal to P2 by T2. Let us solve some problem. Here, the problem is here. A gas cylinder containing cooking gas withstands a pressure of 14.9 bar. The pressure gauge of cylinder indicates 12 bar at 27 degrees Celsius. Due to sudden fire in the building, the temperature starts rising. At what temperature will the cylinder explode? In the question it is given that 12 bar 27 degrees Celsius. Okay? A gas cylinder containing cooking gas withstands pressure withstand 14.9 bar. So from the given data, if pressure is P1 12 bar, what's the temperature by that time? T1 27 degrees Celsius, which is nothing but 300.15 Kelvin. Okay. It can withstand how much pressure? 14.9. So we can raise the pressure until 14.9 bar. To reach this much pressure, what is the temperature? Means the question is, the temperature starts rising. At what temperature will the cylinder explode? Cylinder explode ಆಗಬೇಕಿದ್ರೆ ಎಷ್ಟು T2 ರೀಚ್ ಆಗುತ್ತೆ ನೋಡಬೇಕು. T2 ಗಿಂತ ಜಾಸ್ತಿ ಆದರೆ ಏನಾಗುತ್ತೆ? ಇದು ಎಕ್ಸ್ಪ್ಲೋಡ್ ಆಗುತ್ತೆ. So we have to find out T2. by T1 is equal to P2 divided by T2. Okay, we have to find out T2. So let's find T2. T2 is equal to P2 into T1. P2 into T1 divided by P1. P2 is nothing but 14.9. T1 is nothing but 300.15. P1 is nothing but 12. So we'll get the answer as 372.68 Kelvin by simplifying this. Okay? Initial 12 bar pressure. ಅದು ಎಷ್ಟು ಮಿಸ್ಟೇಕ್ ಮಾಡಿದ್ರೆ 14.9 ಅಷ್ಟೇ. ಸೊ P1 12 ಬಾರ್ ಆದರೆ P2 14.9. ಪ್ರೆಷರ್ 12 ಬಾರ್ ಇರುವಾಗ ಟೆಂಪರೇಚರ್ ಎಷ್ಟಿತ್ತು 27 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂದ್ರೆ 300.15 ಕೆಲ್ವಿನ್. ಸೊ ಪ್ರೆಷರ್ 14.9 ಬಾರ್ ಬಂದ್ರೆ ಬರಬೇಕಿದ್ರೆ ವಾಟ್ ವುಡ್ ಬಿ ದ ಟೆಂಪರೇಚರ್. ಸೊ ಆ ಟೆಂಪರೇಚರ್ ಕ್ರಾಸ್ ಆಗೋ ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಪ್ರೆಷರ್ ಜಾಸ್ತಿ ಆಗೋ ಸಿಲಿಂಡರ್ ಎಕ್ಸ್ಪ್ಲೋಡ್ ಆಗುತ್ತೆ. So T2 we have to find out. T2 is equal to P2 into T1 divided by P1. So 14.9 into 300.15 divided by 12, that is nothing but 372.68 Kelvin. Okay. Let's move to the next problem. Problem of Dodgeda solution is there. A jar contains a gas and a few drops of water vapors at T Kelvin. The pressure in the jar is 830 mm of Hg, and millimeter of Hg. That is the one of the unit to measure pressure. Atmosphere irbodu, bar irbodu, millimeter of mercury. Hg andre mercury. Okay. The temperature of the jar is reduced by 1%. The vapor pressure of water vapor at the two different temperatures are 30 and 25 millimeter of mercury. Find out the pressure inside the jar. Okay. From the above data, we can write temperature T1. ಎಷ್ಟು ಅಂತ ಕೊಟ್ಟಿದೆ. So I take it as T Kelvin only. Okay. What about T2? T2 ಏನಿದೆ? Temperature of jar is reduced by 1%. Okay. ಈಗ 1 T Kelvin ಅಂದ್ರೆ 1 T Kelvin ಅಂತ. ಓಕೆ. ಈಗ 1% ಅಂತ ಕೊಟ್ಟರೆ ಮೀನಿಂಗ್ ಏನು? 100 ಅಲ್ಲಿ 1. ಓಕೆ. ಸೊ 1 T Kelvin 100 Kelvin ಇದೆ 1 Kelvin ಇದೆ how much? So on simplifying we get 1 into 1 divided by 100, which is nothing but 0.01. Okay. ಇದು T in terms of T. Okay. T2 ಈಗ T2 ಏನು ಮಾಡಬೇಕು? ಇದರಿಂದ ಅಷ್ಟು 1% ಲೆಸ್ ಅಂತ ರೆಡ್ಯೂಸ್ ಮಾಡಬೇಕು. 1% ಲೆಸ್ ಅಂತ ಹೇಳಿದ್ರೆ 1 T Kelvin is 0.01. So I reduce T 1 T minus 0.01 T. We get 0.99 T Kelvin. Okay. So we can write 0.99 T temperature times. Okay. What about pressure? Initial pressure, how much is given? 830. But I will clear that cost of the vapor pressure of water vapor and the two temperatures are 30 and 25 mm of Hg. ನಮಗೆ ಏನು ಬೇಕು? ಟೋಟಲ್ ಪ್ರೆಷರ್ ಅಲ್ಲಿ ಆ ವಾಟರ್ ವೇಪರ್ ಮೈನಸ್ ಮಾಡಬೇಕು. ವಾಟರ್ ವೇಪರ್ ಎಷ್ಟಂದ್ರೆ 30. ಸೊ ಇನಿಷಿಯಲ್ 30 ಇತ್ತು. ಸೊ 800 minus 30 is equal to 800 mm of Hg. Okay. ಈಗ next question, calculate pressure. Okay. Find out the pressure inside the jar. We know that P1 by T1 is equal to P2 by T1. Or we have to calculate P2. So P2 is equal to P1 into T2 divided by T1. P1 is equal to 800 T1 is equal to how much? T. Only. You can write in terms of Kelvin. You can write Kelvin also T. Okay. So on simplification, we will get this one as 792 unit is mm of H. Okay. So this is the pressure. But question answer the entire immediate. Find out the pressure inside the jar. Inside the jar, water vapor is there. So water vapor pressure is add model. Water pressure at different temperature stage there are 30 and 25. Initial gate 30, 25 final gate. So idiki diagram ile madagandre total pressure is total pressure inside the jar is equal to E pressure area adike 25 mm of Hg add ಮಾಡಬೇಕು. So 792.25 is equal to 817 mm of Hg. ಇನ್ನೊಂದ್ಸಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೇನೆ ನೋಡಿ. ಏನು ಹೇಳ್ತಾರೆ, ಆ ಜಾರ್ ಕಂಟೈನ್ಸ್ a gas and few drops of water vapors. ಆ ಜಾರ್ ಒಳಗೆ ಗ್ಯಾಸ್ ಇದೆ along with water vapors ಇದೆ. ಸೊ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಏನಾಯ್ತು, ವಾಟರ್ ವೇಪರ್ಸ್ ಇಂದ ಪ್ಲಸ್ ಆ ಗ್ಯಾಸ್ ಇಂದ ಆಯ್ತು. ಓಕೆ, ದ ಪ್ರೆಷರ್ ಇನ್ಸೈಡ್ ಜಾರ್ ಈಸ್ 830 mm. ಅಂದ್ರೆ ಟೋಟಲ್ ಪ್ರೆಷರ್ 830 ಬರೀ ಗ್ಯಾಸ್ ಇದೆ. ಓಕೆ, ದ ಟೆಂಪರೇಚರ್ ಆಫ್ ಜಾರ್ ಈಸ್ ರಿಡ್ಯೂಸ್ ಬೈ 1%. ಅಂದ್ರೆ 100 ಅಲ್ಲಿ 1%. The vapor pressure of water vapor at two temperatures are 30 and 25 mm of mercury. Find out the pressure inside the jar. Okay, temperature initial T Kelvin, but it is reduced to 1%. 100 ಅಲ್ಲಿ 1%. Now ತಗೊಂಡದ್ದು 1 T Kelvin. So 1 ಅಲ್ಲಿ so 1 into 1 divided by 100 is equal to 0.01 T. So T is equal to 1 T minus 0.01 T. Reduce ಆಯಿತು. So it is equal to 0.99 T. Okay. Initial pressure is P1 830, but not only due to gas, due to vapor of water also. So water vapor pressure minus 830 minus 30 is equal to 800 mm of Hg. P2 is equal to how much? So P1 by T1 is equal to P2 by T2 formula. Applying P2 is equal to P1 T2 divided by T1, that is equal to 800 into 0.99 T divided by T. T1 means T. So T get cancels, we get the answer as 792 mm of Hg. But this is the pressure only due to gas. But question is what? Find out the pressure inside the jar. Inside the jar ಅಂದ್ರೆ ಗ್ಯಾಸಿನ pressure plus water vapor pressure and add. Water vapor pressure second temperature is 25. So 792 plus 25 is equal to 817 mm of Hg.